and then we're going to take a look at the scientific approach, skepticism, empiricism, and we're going to focus on induction and deduction. So scientific approaches, if you recall, non-scientific intuition was unquestioningly accepting things. Scientific approach will start off with the opposite of that, which is skepticism, which is to question things, to figure out how does this work, what does this really mean, where did this information come from. And we also have empiricism, which is looking at the world to see what's really going on. So in skepticism, ideas are based or evaluated on the basis of careful logic. So you take a look at the ideas and you say, do these ideas all make sense? Right? Do they follow a logical progression? Is there any contradictions in what they're saying? Are there any logical inconsistencies in what they're saying? You take a look at results from scientific investigations, right? So you go to the journals, you go to scientific publications, you go to studies, you don't go to non-scientific sources. And when we visit the library, we'll see how to find those scientific sources. But you evaluate ideas, and again, you question using careful logic, question using these scientific investigations. Empiricism is another scientific approach, and this is knowledge based on observations. And notice it's observations, not observation. Observation is anecdotal evidence. If you see one thing, that's anecdotal evidence. But if you see it 100 times, 1,000 times, if you see it multiple times, then you can see a pattern and you can get to the truth. So in that police study on the Black Lives Matter issue that I showed you, they looked at data of all, police homicides. Sorry, that's not the word. All, I forgot what the term was. They all uses of lethal force. There it is. They looked at all uses of lethal force, not just one, not just the ones that made it to the news, but all of them. They based their knowledge on those observations. And then the other one that we're going to take a look at today specifically is deduction, and the flip side of that, induction. And those are two forms of, again, ways of knowing that are based on, in the one side, logical, careful logic and skepticism, and induction is based on observation, more empiricism. All right, so let's get to induction and deduction. So again, induction based on observation, deduction based on logic. Induction is when you reason from a particular piece of data to a general theory. Deduction, on the other hand, is when you reason from general theory to a particular piece of data. So you'll notice that these two are flip sides of each other. So induction, you take a look at something and then you generalize to a theory. Deduction, you take a look at a theory and you generalize to a particular situation. So I'll give you an example of induction. So this is a simplified example. If you're critically thinking about what I'm presenting right now, you'll notice that this is anecdotal evidence. So again, we wouldn't accept this unquestioningly, but it is an okay place to start. So we have a single individual, and let's say that this is a friend of yours, and he paints, and he's a bit of an introvert, and he's good at solving problems, but he's also been breathing in a lot of fumes, so his cognition is a little bit slow. And what else do we have? He has low income because he's a starving artist, and he breathes in paint fumes. He's got slower cognitive functioning. He's great at problem solving. He's very creative. These are all things that you observe about this particular individual. Those are all pieces of data. So all those observations, all those facts about this individual here are pieces of data. Induction is when you reason from that data to general theories. So you might know that he is creative and he's a great problem solver. So you might induce from that and say, you know what, maybe creativity actually leads to better problem solving. Maybe those two are related. He's creative, he's good at problem solving. I'm going to induce this theory that creativity leads to better problem solving. And you might say to yourself, he's kind of introverted, and he's struggling as an artist, he has low income, so maybe people with low income are more likely to be introverts. I'm going to take those two pieces of data and I'm going to induce a general theory. So it's true of him, we know it because we've seen it, we've observed it. So maybe it's true of all low-income individuals, they're more likely to be introverts. And lastly, he might be good at problem solving, but his cognitive functions might be slower. You notice that he breathes in a lot of paint fumes because of his job, and you might say to yourself, maybe fumes from paint leads to slower cognitive functionings just in general. So we're going to talk more about induction next time, but one thing to notice here is that in each of these cases, I kept saying maybe, right? So he is creative and he is good at problem solving. So maybe creative people are better at problem solving. He has low income, he is an introvert, so maybe introverts are more likely to come from low income brackets. So that maybe is very important. That's going to come up later because observations do not guarantee that your generalizations are going to be correct. On the other hand, we have deduction. And deduction is when you go from a general theory, a general idea, to a particular piece of data, a particular prediction. So let's say that there's a theory out there that says that job stress leads to depression when income is low. All right, so the theory is that if you have job stress, you are at risk of depression, but only when your income is low. Higher income, you're not at risk of depression regardless of how stressful your job is. So let's say that that is a theory that has evidence for it. It's a theory that's been shown to be true. We could then predict what would happen in specific situations. So we could say, for a telemarketer, the theory says that job stress leads to depression when income is low. So a telemarketer has a high stress job. Has anybody ever worked as a telemarketer? No? It's not fun. One of the things, I've never worked, but I have known people who have. And one of the things that makes jobs stressful is when they're unpredictable. Does anybody know and you have no control over what happens. So one of the most stressful jobs, I believe it's usually in the top 1 or 2. Does anybody know what it is? It's being a waiter or a waitress. Yes. Because you have no control over people's reactions. And what makes it stressful is that unpredictability of whether they're going to like their food or not, whether they're going to like their service or not, things that you have no control over. So telemarketers are in the same boat. They never know if they're going to be dealt with politely, if they're going to get screamed at on the phone. Highly stressful job. So, job stress leads to depression when income is low. They have job stress. They have low income. Therefore, we can predict that if we were to look at telemarketers, they would be more depressed than your average individual. They should have more depression than average because of this theory. So if this theory is true, telemarketers should be more depressed. We know that before even measuring their levels of depression. On the other hand, surgeons have very highly stressful jobs, right? Surgeons are in life and death situations. Sometimes they're pulling extended hours. They have high stress in their jobs, but their income is not low. They actually have high income. So job stress leads to depression when income is low. They have stress, but they have high income. Therefore, we can predict that doctors will be less depressed than the average individual. So once again, we might have never measured the depression of doctors. We might have never measured the depression of telemarketers. But through deduction, if this theory is true, then we can predict for that situation, telemarketers will be more depressed. If this theory is true, then we can predict for this situation, doctors will be less depressed. Any questions so far? All make sense? All right. So, induction, you start with data, you end with a theory. Deduction, you start with theory, you end with the data. You end with a prediction, or you end with data. And this is what I like to call the wheel of science. Basically, if you're a scientist, if you're an experimental psychologist, if you're looking for new knowledge, what you're doing is you're doing a constant cycle of induction and deduction. And that's how the science moves along. That's how the field advances. So you might start with a theory, right? So if you have, let's say that you're working on a treatment for depression. You might start with a theory about what causes depression and how certain drugs work. From that theory, you would make a deduction. So you would say, if this is how your brain works, and this is how this drug works, then if we give people this drug in this dosage, their depression should go down. So through deduction, through this logical deduction, you lead to a prediction. That prediction is, in this case, depression should go down. You then go out, run the experiment, you collect the data. If the data is the same as your prediction, then you go back up here, you make a new deduction, you make a new prediction, you do another experiment. If it's the same, you go back up here, make a new deduction, new prediction, you do another experiment. If your prediction does not match what you find, then what you need to do is you take this new data and you make a new induction. If you don't find the prediction, that means your theory is incorrect. So you now have to induce a new theory, and you start the process all over again. So you then, with this new theory, make a new deduction that has a new prediction. You collect the data. If that theory is wrong, you then induce a new theory, new deduction, new prediction, find the data. If that theory is wrong, you then induce a new theory, and you go around and around and around, coming up with new, better theories, replacing older theories that don't work. So this wheel of induction is how ideas like Freud's psychoanalysis eventually got discarded for behaviorism, and then behaviorism eventually got discarded for cognitive psychology. It's how new theories emerge and old theories get discarded. And each kind of spin around this wheel gets you closer and closer to the truth of what's actually happening. And the importance of deduction in psychology cannot be, I think, overstated. It's an incredibly important tool for a variety of reasons. One of them is that the list of variables that can potentially influence behavior is infinite. Right? We are complicated creatures. Human beings are on levels of complexity far beyond, almost anything else that we find in the universe. And without deduction, without using logic to narrow our focus, then what we're doing is basically blindfolding ourselves, picking up a bunch of darts, and just throwing, darts wildly. We don't even know what the wall is, right? So all of these darts over here, these are all wasted effort. So if you're trying to cure depression, what about increased TV time? What about eating more greens? What about reclining your chair further up than further down? What about washing your face in the morning? There's millions of things that you could potentially look at. Most of them are going to be completely useless. So as psychologists, we don't want to waste our time. We want to help people. We want to get to the truth as quickly as we can. So we use deduction to narrow and guide these. So we start with theories. We start with the work that has been done previously. And we say, based on that, where should we look next? Based on that, what is the most promising area? And you get that through deduction. And then oftentimes, especially when you're pushing the edge, when you're pushing the boundaries of what we know about psychology, existing theories are not going to deal with any of the variables of interest. So sometimes you're going to come up with a problem, and there's not going to be any variables or work that has been previously done on that. So an example that occurred very recently in psychology is the effects of social media. You can't go back decades and look for research on social media. It didn't exist, 20 years ago. So sometimes you're like, well, what is social media going to do? How's that going to affect our behavior? And you can take a look at the research, and there's nothing on social media because it's a brand new phenomenon. So what do? Well, you look at other theories that kind of tangentially affect it, and you need to deduce new predictions. So you look at theories on human interaction, you look at theories on availability of information, you look at theories on how choices are made, and then you say, all right, based on all these things, this new phenomenon of social media should cause these behaviors. So that's what you need to do to deduce those new predictions, and you're going to see that you're going to need to do that as well in our in-class experiment, because our in-class experiment is on group memory and false memories. And what you'll find when we do our library assignment is that there's a ton of research on groups, and there's a ton of research on false memories, but there's not a lot on group false memories. So we're going to have to take a look at what do people know about how groups operate, and what do people know about how false memory operates, and then using that information, much like you deduced in this exercise, deduce predictions about how group false memory should work. So just to kind of foreshadow what's coming up, now that you know the importance of deduction, it is vitally important that we develop these skills. And one of the best ways to develop deductive skills is to actually do deduction. So I have provided a link. This was printed off from an online resource where they can generate infinite numbers of these logic puzzles. You can choose between different levels of difficulty. So I provided that link in Canvas. So I would highly recommend practice these a little bit, because I do offer bonus points on the exams, and the bonus points come from logic puzzles like this. So there will be one of these on every single exam for bonus points. So that's to encourage you to develop your deduction skills so that you can, number one, be a good psychologist and be able to use these tools. Number two, maximize your scores on the exam.